naming polycyclic molecules, we're going to begin with fused rings. This fused ring has the trivial name of Decalin. But what's its systematic IUPAC name? Well, any fused ring can be described as Bicyclo, so that's a great place to start. But clearly we need more information. Next, we're going to consider the relationship between the hydrogens that are attached to the carbons that share the fused bond. These hydrogens can either be on the same side of the ring, so cis, or on the opposite sides across from each other, that's to say, trans. Hopefully, you can identify that this particular case has a relationship between the two hydrogens that is trans. Next, we're going to identify the common carbons in this fused ring system. If when you break a bond you get one ring and one chain, the carbon of the broken bond that's part of the ring is a common carbon in the original bicyclic system. Here they are. Now we're going to count the number of carbons in between these two common carbons. There are three paths to consider here. This path has 4 carbons in between the common carbons. This path again has 4 carbons in between the two common carbons. And lastly, don't forget this path. It has 0 carbons in between the common carbons. For a fused bicyclic system, one of the paths will always be 0. We record these number of carbons in between a path within square brackets, and we put a dot in between each number. This gives us 4.4.0, going from the larger number to the smaller number. Lastly, we need to look at all the carbons in the ring system. We have a total of 10 carbons. Thus, we would call this decane. So we have a systematic IUPAC name for this molecule of trans bicyclo 4,4,0 decane. Now, this particular fused ring structure occurs quite commonly in natural molecules known as natural products, such as steroids. Here we see the steroid testosterone, and within it you can see the structure of trans bicyclo 4,4,0 decane. Now we're going to consider bridged rings. We're going to use a very similar technique when it comes to naming bridged rings. Firstly, again, it's a bicyclo system. Next, we want to identify the common carbons. Here they are. And now to count the number of carbons in between these two common carbons. This path has 2 carbons. This path also has 2 carbons. And this path has 1 carbon. So 2.2.1. Lastly, again, we're going to look for the total number of carbons. We have a total number of carbons here of 7, so that's heptane. The full systematic IUPAC name for this molecule is Bicyclo 2,2,1-heptane. This molecule has the trivial name of Camphor. It smells lovely. But you can see the Bicyclo 2,2,1-heptane structure within it. Let's take Camphor and strip away the distracting functionality of this discussion. Here you can see the bridged ring system, and you can see almost why it's called a bridge. The main outer ring has a bridge crossing it. The two Common carbons are also known as bridgehead carbons. They have some distinct chemistry. So both fused and bridged rings are described as Bicyclo. We number the paths from the largest to the smallest number of carbons in that path. So that's to say here 440 and not 044, and 221, not 122.